Welcome back, folks. I'm thrilled to have you here with me today for another exciting topic, load balancer. So, a load balancer, as described in your scenario as a network engineer, migrating to Azure is going to be a very crucial component for distributing network traffic across a group of backend computing resource or servers. Its primary purpose is to ensure the even distribution of incoming network traffic, optimizing resources utilization, maximize throughput, minimizing response time, and preventing overloading of any single resource. Some of the key topics about load balancer are going to be distribution of workload, resource optimization, high availability, scaling appliance or applications, inbound and outbound traffic, low latency, a layer 4 load balancing mechanism, session affinity, public and internal load balancers. We are going to discuss all in details, topic by topic. Distribution of workload. As I mentioned earlier, the load balancers evenly distribute incoming network traffic among the group of backend servers, which we call pool. This is to ensure no single server become overloaded and the workload is efficiently shared. I may not need a load balancer. So let's try to understand why do I need a load balancer first of all. I might have a server. So in this example, let's consider this is a standalone machine and you can run this as a web server and the initiator can request on port 80 or 443 to access the resources. But there are going to be limitation in terms of CPU, RAM, number of sessions on this virtual machine. So it might not be very appropriate to handle the large load. That is the reason we are going to put another gear which is going to be the load balancer. And in this case, if the request comes like this, so in this example, we can see there are three requests, request 1, 2, and 3. Once they are going to hit this load balancer, it becomes the responsibility of load balancer to distribute evenly. So my first request goes to my web server 1, second goes to second server, and third goes to my virtual machine 3. That is how it is going to distribute the load. How it does that, it is going to be based on a hashing algorithm. So let's understand what is flow. So in this example, let's say this is the initiator and I'm running a web server on port 80 here. The moment it is going to initiate some traffic, it is going to open a random port on this machine and remote is going to be well-known port. Random port means there are going to be limit of ports on a machine, which is going to be 65,535. So here it's going to be a random value and the remote value is going to be a fix. When you take a look on the TCP IP stack, this is the TCP. This is going to be the source port, destination port. And here you have source address, destination address, and the protocol mentioned. So when you are forming a flow on that basis, a hashing is going to generate to redirect traffic to the pool of resources. So it is going to be based on your source IP address, source port, destination IP address, destination port, and IP protocol number to map flow to available server. Let's talk about session affinity. So it all depends whether your application is stateful or stateless. If it is stateful, then you are going to use this session affinity settings. Load balancers often provide session affinity settings, allowing you to maintain session persistence. This ensures the subsequent requests from the same client are directed to the same backend server. Session persistence is also known as session affinity, source IP affinity, or client IP affinity. This distribution mode uses two tuples, which can be your source IP and destination IP, or you can go for the three tuple settings, which is going to be the source IP, destination IP, and the protocol type to hash to route to the backend instance. When using session persistence, connection from the same client go to the same backend instance within the backend pool. So we talked about load distribution, and that time I had mentioned that you are going to use the 5 tuples. So if you're not going to configure the session affinity, that means 5 tuples will be used to choose the backend member of the pool, or you have an option, you can go for the 2 tuple persistence or 3 tuple persistence. Azure Load Balancer is also going to support your inbound and outbound traffic, which means if the traffic is originated from internet, that will be hitting your load balancer, and then the distribution of traffic will be taken care by the load balancer itself. And same time, if this is a virtual machine, it wants to originate some traffic for internet, that can also be handled by your load balancer. So you can configure your inbound and outbound traffic rules. High availability. So load balancing enhance availability by directing traffic to a redundant computing resource. In case one of the server or resource fails, the load balancer can automatically redirect traffic to the healthy resources to minimize your downtime. So what it mean by that? As of now, let's assume this pool of 3 virtual machines, this is healthy. So all these 3 requests which is coming from internet, or maybe they from the internal network, they will be served by these virtual machines evenly. So my first request comes to virtual machine 1, second goes to virtual machine 2, third goes to virtual machine 3. What if this virtual machine fails? It is then in that case, this machine will be out of rotation and this request will be redirected to the healthy resources. That is how you minimize the downtime of your application. The Azure Load Balancer, it can handle million of requests. So while designing a pool of virtual machine, you need to consider this is fully managed and it can handle million of requests, can expand and shrink automatically. To handle million of requests, you need to provision your backend resources as well, because ultimately all those requests will be landing to these virtual machines. So you have two options. You can manually adjust your virtual machines pool while adding or removing the virtual machine from a pool, or you can go for VM scale set where you are going to do a deployment, and this deployment basically will be adjusted. So for example, when the load increases, it is going to add these virtual machines. Those are going to be very, very similar in the nature. So, and when this load is reduced, this machine will go off. So this is all will happen automatically. But high availability is not limited to this much of design. What you need to consider, since your load balancer is going to be a regional component, so you need to consider whether you are going to deploy all these machines in one zone or it is going to be zone redundant. If it is going to be zone redundant, no matter if one of the zone or two of the zone goes down, it might be served by the zone where your virtual machines are healthy. I'm going to explain high availability topic a little more when it comes to the Azure Load Balancer. So an Azure Load Balancer has two types, public and internal. And throughout this course, I'm referring this to a standard load balancer. Both type of load balancer supports zone redundancy and the zonal deployment. Both load balancer type can direct traffic across zone as needed. Availability zones are something which you should understand before you design your load balancer. So availability zone, you might have multiple availability zone, and combinedly that is going to create one particular Azure region. And the whole infrastructure is like that so that you can sustain the failures. Maybe for a reason this zone goes down. You might have your workload running from zone 1 and zone 3. This component, Azure Load Balancer, what we are talking about is going to be a regional component. So it cannot spread across multiple regions. So in a particular region, you need to do a deployment and then you need to consider how you are going to basically put your workload, the pool members we talked about. Load balancer zonal architecture. So basically, what we are going to talk about how this zonal architecture works and why do you need the zone redundancy to make or achieve high availability for your particular application. So a zonal component, it is deployed in a specific availability zone that you select. In the previous diagram, you might have seen multiple zones are available in a particular regions. So while you deploy those components, you have an option to choose a particular zone. This approach basically helps you to achieve very strict latency, performance requirement to pin your multiple resources to a specific zone, ensuring traffic between them doesn't have to travel far. A zonal approach doesn't give you resiliency. In the case a zone fails and the zonal services fails, your zone will become unavailable until zone has recovered. Means in a zone failure scenario, your application is going to be unavailable. Couple of things you can do here. If you see, this is LV1 and I have a pool of my resources in subnet 1. Then I have LB2 in subnet 2, LB3 in subnet 3. This is zone 1 deployment, this is zone 2, this is zone 3. This is going to work and you are going to have public IP address here, one here, and the third one here. A trick you can do here, basically, you can put a GTM on top of that. And for GTM, you can refer to my another video. And this GTM you can play based on DNS if you really want to do some sort of the load balancing. So any request which comes here, this will be redirected based on different threshold and the rules you configure. But if this zone fails, the whole service will go unavailable. Zone redundant load balancers are basically used in availability zone scenario where we require that the application is not affected in response due to the zone failure. With the zone redundant architecture, Microsoft's going to manage distributing your traffic between the availability zone. So in this case, it's just going to be the one IP which is going to be available across all the zones. And if this zones or maybe one of the zone, if this goes down, your traffic will continue to flow for rest of two zones where your workload is available. There's one more option available, which is going to be the cross-region global load balancer. And this is going to be a Azure standard load balancer, which supports cross-region load balancing while enabling geo-redundant high availability scenarios. There are definitely some of the limitations which you need to consider before you design it. Cross regions front-end IP configuration are public only. So it is a kind of load balancer. Under the pool, you are going to have public load balancers. Those are deployed in different regions. You will not be able to add any private or internal load balancer to the backend pool of this global load balancer. So some consideration before you design it. Let's take a look on Azure Load Balancer topology. As I mentioned previously, your load balancer can be public or internal or private. So when I'm saying internal, it means it's a private load balancer. Azure offers both public and internal load balancers. Public load balancers, they have a public IP address. So for example, in this topology, I have this load balancer as public. It means I need to assign a front-end public IP address to this load balancer. However, this load balancer, the second load balancer, what you see, this is going to be the internal. That means the IP assignment is just going to be from the subnet B, and it is not going to have any public IP address assigned. So internal and private load balancers have RFC 1918 private IP addresses and are used within your virtual network for internal traffic distribution. So if you take a look on this topology, it means some traffic which is coming from internet. It is going to hit your load balancer, and I consider this zone as a DMG. This is going to be your web front end, and then you're going to have some sort of the application which is hosted in subnet B that is going to be completely private. And to do that kind of the distribution, you are going to put a load balancer which is going to be private in the nature. So all the requests which is going to hit this load balancer goes to the web server, and from web server it is going to originate another request which is going to hit your load balancer to reach out to your application which is hosted as a part of subnet V. It is important to note that they may not offer the same level of advanced metrics and intelligence as some third-party network appliances like Barracuda or F5 network load balancers. Depending on your specific requirement, you may choose to use additional tool or services to gain deeper insight into your network traffic and the performance. Thank you for watching, and I will see you in the next section.